Hi, I'm Aram Mahmoud, integrated digital delivery engineer team leader. Today I will share insights on the integration between BIM, planning, cost, and warehouse management. Our case study consists of three buildings here: building 3, building 2, building 1, and the main warehouse in the project. Here are our data: the activity ID, activity name for planning schedule here, and the cost data. Here is the cost ID and the indirect cost as shown here. Now we have to insert this data into our Revit model here as shown. All data are empty: boring data, stale data, formwork data. These parameters represent the activity ID or the planning data, and the cost ID here is empty. In this building, all data are empty. In this building, all data are empty. So we will fill these parameters using the Dynamo. Now we will open our first building, B01. Here is our building. All data is empty here. I will open now the Dynamo to insert the data. Here is our script to insert 4D, 5D data. Here is our script. This part represents the activity ID and this part represents cost ID. Now we will insert our data here. Here is our building number here, B01. The data is empty here as shown. Just run the script and our data is filled here as shown. Here are our data here. So we can insert our data quickly by Dynamo. Just save our building on and we'll continue this process for other building. Now we will open building B02 and insert our data using Dynamo. As shown here, the parameters empty. We will open Dynamo here. We will open our script. Here is our building. The parameter is empty here. You will change the building name. It will be building 2. Just run the script and our data is filled here as shown. Our data here as shown. B02. Just save and close and we will open the final building here. We will open our last building B03 to insert our data using Dynamo. Here is our building. The data is empty here. The data is empty here also. We will open here Dynamo to insert our data. We will open our script. Here is our building name and here is our script. Our building name is base B03. Just run the script and here our data in the parameter as shown here. And we will save our project now. Here is our project. We will load our building here, B01, B02, and B03. Let's check our data here. Here is our data for building 03. Our data for building 02. This is our building 1. And there are our data here as shown. So we successfully inserted our data of activity ID and the cost ID to our building in the project. After inserting our data into Revit, the next step is to upload our project into the VCAD software for analysis and visualization through Power BI. Here is our software VCAD and our project here. We will upload, then we will drag our project to VCAD. We will select the host model is the site layout. Then we will upload and waiting for uploading our project. Our project is successfully uploaded on VCAD and now we will download our template. Now our project is downloading. You will open our project now. Here is our project on VCAD. Here are our project here. If we selected any element here, as shown, it will be represented in VCAD. Now we successfully inserted our model into Power BI through VCAD. And then we will insert our cost planning data into Power BI to create integration between them. After downloading the Power BI template, I have inserted cost data, indirect cost data, planning, warehouse expense, warehouse supplies. I have created also 4D dashboard, cost dashboard, 4D and 5D, and the warehouse dashboard. I also created our relationship between all data as shown here. Let's focus on 4D dashboard. This dashboard represents planned versus actual progress. I have here baseline start, actual start here, and the activity status filter. When I choose complete, it will represent the completed items in the site and the not completed item in the site as shown here. When I select date here from baseline start, let's choose this date. And it choose the same date in the actual start. It will represent the planned versus actual as shown here in our model. There are some elements here, like columns, are not here in the actual visual. Let's choose another date. And choose the same date from here. As shown, there is another difference between planned versus actual as shown here in our 4D dashboard. Let's go to cost dashboard. Here is total cost, total indirect cost, cost of building, indirect cost of building, cost by months, indirect cost by months, total cost by category, the baseline project cost and the actual cost by months. Our categories here. If I choose here RC foundation, it will affect our visual. Vertical element at second slab, fifth slab. If I choose our building here, building 1, building 2, building 3, this is our cost dashboard. For 4D and 5D dashboard, it represents the planned visual here and the actual visual. Planned start date, actual start date, total volume for planned cost, indirect cost, total volume for actual cost, and indirect cost. Actual body quantity by month, activity status. If I choose here a specific date and choose from the actual the same date, we will see the difference in model here. There are some elements here in our planned visual, and the difference also in total volume here as shown, and the planned cost versus actual cost. If I choose another date and select the same date here, here is our visual here in the same date. Select another date. We will see the difference in model here from planned and actual, and this is the difference between total volume here and here. What about actual body quantities by months? If I choose here May, our months, you will see the body quantities in May. What about June? Here our body quantities. What about July? Our body quantities. What about April? Our body quantities here. What about the warehouse? Here are our total supplies by ton, total expenses by ton, total remaining by ton. Warehouse cost by diameter, our diameter here T8, T16, T12, T10, and total price for expense or supplies. Here is the quantities. Above was the cost, and here is the quantity for each diameter, and here are the remaining quantity by diameter in the warehouse.